This is a Beretta A400. It's the most cutting-edge semi-automatic Beretta has ever made. Whilst I was out at Beretta a few weeks ago having a stock made for my DT11, they asked if I wanted to look around the semi-automatic production plants, and of course, because I'm fascinated by all things gun making, I said yes. We're starting at the receiving end of the workshop.
Yes, so here is basically where we receive all the machine parts, but also the parts that come from the suppliers. The metal is done by Beretta internally, and other parts such as polymers are coming from the outside. Quality control is very high internally when we receive the parts, but of course we don't have the capabilities to mold directly, for instance. And we are pretty busy in developing new barrel technology, new receivers, by new machining for the metal parts again. So
it's all designed here, the whole concept, the prototyping is done here.
Absolutely, yes, absolutely.
It's great to see openness about where these parts are made. Metal components like barrels and actions are in-house, but molded parts are outsourced to other specialist Italian factories. All of these parts then go through quality control and meet in this room. With the basics established, I started my barrage of questions.
This is two parts.
Yes, exactly. It's a barrel plus the barrel extension. So the barrel extension is chromed outside, but we do screw in the barrel with the barrel extension. So the barrel extension has a dual purpose. On the one hand, it keeps the barrel inside the receiver. On the other hand, though, you can see that has the extractor here.
The ribs and the gas port are connected downstairs in barrel production.
Absolutely.
And this is assembled downstairs as well?
Yes. So the barrel is attached to the gas cylinder, and you can see here that it has a valve.
All Beretta semi-automatics are gas.
We chose to do fully gas gun, especially with reliability, gas helps. So all our semi-auto gas guns will cycle all loads from 2 3/4 up to 3, if chambered 3.5, but from 24 grams up to 64 in super magnum chamber guns.
And it's this regulator that makes that happen, because anything over certain
Exactly.
pressure to cycle the gun bleeds the gas out.
Exactly. This is basically a valve that opens up when the gases create too much pressure inside the cylinder, and you don't want the ball to be pushed inside the receiver too fast. So that's why we engineered a valve that lets the exceeding gas outside, and it's very peculiar to our A400 series that we currently produce.
I've always dirtied everything that I found. This ain't no difference, so look at you now. Baby, cut yourself.
The A300 and A400 series are different, the latter having a rotating bolt head versus the traditional lifting bite.
Yes.
What are the benefits of a rotating bolt head?
So the A400 series, as you mentioned, was engineered, I think, less than 15 years ago here in Italy. It was developed to cycle and run properly super magnum 12 gauges. That was the main thought on the A400 series. Here we do have a barrel extension, as we saw before, and also a chrome head that rotates into the barrel extension and locks it automatically. But the A400 series is renowned to be faster. That's because of the chrome components, but also the two rods instead of one just operating rod. All the, let's say, operating and moving parts are better than the A300.
And faster is better.
Faster is better, but also more reliable sometimes.
Efficiency equals speed, but it's the efficiency is the real thing.
Yeah, efficiency, yes. We want to talk about efficiency. Also about it is smoother to shoot compared to the old models. It is also more reliable.
The gas piston changed as well with the update massively over the old 391 and 300.
Yeah, absolutely. So as we see here, we got the A400 or 1301 gas piston. What we have done really is because, of course, gas is not very clean from a user point of view.
It's the main downside of a gas gun is you have to maintain it.
20 years ago, when you were dealing with gas gun, they would get dirty. The dirt was stuck into the cylinder and the piston, and at the very end, they would
a penknife chipping it out.
Exactly.
I have fond memories.
Yes, but also it would get stuck, and the gun after a while wouldn't cycle anymore. So what we have done here is basically made a ring that when cycling, it moves itself and doesn't allow the dirt to stuck into the cylinder.
So this is the gas seal.
Exactly, basically yes. So when it moves, when the gases are coming from this way, they hit the piston, but also they will move this ring.
It's self-cleaning to a certain extent.
Exactly, and that's why we market our gas system as a self-cleaning mechanism, because of this new concept of a piston that doesn't allow the dirt to stuck into and on it, really.
Pietro then explained that with a quality clay load, you can shoot upwards of 10,000 shells without cleaning. But obviously, the gun, like any other, would probably be happier if you actually looked after it. All of the raw parts of the gun are brought down the room to be assembled. This is done over 2 stations, one assembling the magazine tube and bolt release, and the other fitting the bolt assembly, piston and barrel. The guns are then tested with gauges and lubed up, ready for the first round of testing.
So all the metal parts, as you can see here, are assembled. Here are assembled the bolt, the trigger group, of course the bolt release lever, all the bolt assembly, the piston, and of course also this rod here that keeps also the stock together.
It's fair to say that the semi-automatic side takes a lot less handwork than the over and unders. This is bolting parts together.
Yes, the tolerances are quite different from an over and under. I'm not saying that one is better than the other, but of course on a semi-auto is a less complicated gun from an end work point of view.
I think with an over and under, you're trying to hang barrels that open and have a tight gas seal.
Yeah,
the best engineers in the world still need to hand fit those parts together, whereas this with a rotating bolt head,
yeah, it's less complicated, let's say, and of course you work on the engineering side to make it work the best with the things that you have.
You were saying earlier that the trigger unit is not made here.
It's engineered here, of course, but is assembled at one of our partners. We work together with them very well because of a reason, because they are partners and not just suppliers.
My big question for the A400 series and the 1301 series is, use of plastic as part of a semi-automatic has been dogged on, let's say, by the old school. Why?
Well, the thing is, plastic was considered bad, let's say, in the 80s, in the 90s, but now polymer, let's say, highly engineered polymers has now the benefits of wood, of metal, and more. If you think about maintenance, for instance, very well engineered and made polymer will last thousands of years, while metal may not, wood obviously may not. So we do find that polymer has some benefits.
You've got the spring guide.
Yeah, absolutely.
And the trigger unit. That's the plastic.
That's the plastic, really. All the other things, as we already mentioned, is either aircraft aluminum or steel. So you won't go wrong with them.
Something like a spring guide probably couldn't be made out of metal and have the same effect, right?
Yeah, and that's because of wear, because of weight savings. It does have some pros, polymer, if not only pros.
So the gun's pre-assembled without furniture.
Yeah.
At this point, it should be operational.
It is operational, and we double check it with this machine over here. That basically is running in station. We run the bolt a few hundred of times without any active loads in it, just to make sure the tolerances are wear down.
I guess this machine removes the need for people to run in. You just get it and it should clack away. It's not very fair to let the end user do the quality control.
Absolutely, and that's why we do it here.
Once the gun has passed this first round of testing, it moves down the line to have the barrel, bolt and receiver marked with the gun's unique serial number.
We got laser engraving here to serialize all the, let's say, the gun parts of the shotgun. That's for the Italian government what they say it is a gun part, so it needs to be serialized. And then they go to the proof house. So with all the serial numbers already laser engraved on steel or aluminum.
The reason that's done at this point and not earlier like in other processes?
Because the breaking in is the most fundamental part of this process.
Okay.
Here.
So if something fails at that point, which is unlikely,
you don't want to get wasted. Really.
Yeah, you've not had to serialize 2 bolts, complicate the process.
Exactly.
The guns then go off to the Italian National Proof House, which is luckily right next door to the factory, to be subjected to a series of very heavy loads. These test the integrity of the barrel in action, and a gun can only pass when no deformation or damage to any component part is present. Once they've passed, they return to the assembly line.
After proof, furniture fitting.
Absolutely. So, of course, you have in hand a Cerakote and a camo version of the Extreme Plus. Some fitting might be required, of course, especially on boot models for semi-autos. But here is where, from the metals, also the other parts in polymer and also in wood are attached. And then the gun is sent to our internal testing concerning reliability.
This reliability testing happens downstairs, alongside some of Beretta's other models. Each gun is set into a vise to add some consistency to the testing. Then, depending on the chamber size and caliber of the auto, a different series of loads is fired from the gun to make sure that it fires, ejects and feeds correctly.
So every gun is subjected to a test with 24,
28, 32, and Magnum or Super Magnum test.
and if it doesn't cycle, it comes back upstairs.
Yes, we have a dedicated workshop here with an expert that takes care of this issue. Not that every single gun has this issue, but we want to make sure to address the problem here at the assembly line. After that, the reliability test, very important for us, they come back.
So any issues that arise are fixed, and then it's sent downstairs to be checked again. The whole process we'd seen so far was very streamlined, but when you consider the quantity of guns running through this room each year, any time spent dilly-dallying soon adds up.
After the reliability test, guns come back in to the assembly line. We have a finalizing inspection area, and then after we have done that, they come here to the boxing department, where they are disassembled again. They place them into the box and they are shipped all over the world.
That's pretty clever, right? I expected it to be a lot simpler than the over and under stuff that we've looked at in the past, and it's a lot simpler in this process. Getting it to this stage probably takes a lot more work.
Yeah, absolutely. The engineering that goes into semi-autos, we talked about, trigger groups, for instance, they are overlooked sometimes by the end user, but making a semi-auto work is a lot of work, not just on the assembly line stage, but generally speaking from the engineering side, also to the industrialization side. It takes a lot of effort, it takes a lot of time, it takes a lot of experience. And here at Beretta, we feel like we know how to make things work, especially, but not limited to semi-auto.
Thank you, man. That was genuinely fascinating. I don't know about you, but that few hours spent in that room really did increase my appreciation and understanding of semi-automatics on the whole. Being a Brit, generally speaking, we like guns with 2 barrels. The more I learn about semi-automatics, the more I understand that they are actually good value for money. Given that the scale of production is large, the unit cost is kept at the price, but the investment in technology is still high. Guys, thank you for watching. Thank you very much to Beretta for letting us have a little look around, and thank you to them for supporting the channel in the way they do by allowing us to have a look around and play and giving up cool information about the way these things are put together. Because, well, I appreciate it, and I hope you do too. Take care, guys. We'll see you next time. Thank you for watching, guys. This channel is made possible by our amazing sponsors. You can find out more about them in the description down below. And if you want to support the channel, you can join as a member. You get loads of extra content, well, some extra content, and occasionally we hook up and go clay shooting together as a membership group. If you don't feel like joining today, we really appreciate you watching and subscribing. Have a wonderful day.